Hello everyone, this is the episode 4 of the KTaNE custom module making tutorial. Today we are going to talk about the scripting, and this video is going to be different because I'm not going to script live on this video, but I have created the working script file for this module already, as you can see here, and I'm gonna walk you through the important points in scripting a module for KTaNE. I assume that you already know how to code in C# already, so let's begin. The first thing you want to do is adding a script file to your module. Basically, select your module, then press the Add Component button, search for script, select New Script, and then you have to name the script, set your language. I set the C#, and then push the Create and Add button. And then the script file will be added to your module just like this, and the file will be visible in your assets folder. To edit your file, you have to press the Open button here, which will bring up the Mondo Develop it or Visual Studio based on your preference. I'm not gonna do that, or else my computer will run out of memory. Also make sure that after you add the script file, drag your module down to the asset folder to save as well. Then about scripting, I have tons of points to talk about. Okay, so in this code, the first point you want to see is the using block here. Basically, you have to include all of the functions you want to use in your program. This is the default block I commonly used. The Newtonsoft.json is used for mod settings, which I will talk about it later. Regular expression and collection generics is, and basically I think I'm going to use it for Twitch plays coding, which I haven't done yet. It will be in the separate video later. The KM helper one is also will be in a separate video. It is linked to a file called kmbomb.info extension made by Ash the Bash. This is not the file. This is included in the mod kit. You have to add it yourself, and I will make a video about another video about it later. This block is created by Unity itself, the class for your module. Then of course you have to declare some variables. Note that these have the public settings and below have private settings. The public settings above are the settings that you want to have the objects binds to it in Unity, because only the public settings will be displayed in Unity, private will not. So basically I declare audio for playing audio files in the module for accessing our module in transform or to handle pass and strike, info for getting the age work info, mod settings for getting the setting files, and then I have to get the button press as well, such as the numpad, the go and submit button, and then text match for accessing the screen, and text on the go button for changing its color, the bar control game object for scaling the timer bar, and the last thing is the mesh renderer for the bar and go button to change their colors. And then after you declare this, you go back to Unity and it will load the script, then you can see all these objects binding options here. First, all of them will be null. You can then press the circle and assign the proper objects to it. For audio module info mod settings or something like that, you will want to add your module as the object, and it should have only one item here. And then just assign all the buttons, the text mesh, mesh renderer, game object, or anything. The Unity should filter available and valid objects for you automatically, so you don't have to worry about that. Okay, go back to our code. The next thing is the ID based locking. Here you must have this block of code in your module, this one and this one, because there's a lot of players who use the locking for analyzing their gameplays and improving their gameplays, and this will help them, these codes will help them keep track of which modules they are looking for. You can copy these blocks of code and paste it accordingly into your code, and I will explain later how these are important. Okay, so these are for the ID based locking. Examples will be around here. For example, this line here, as you can see, you have to run add the command debug.log format, then add your name, your module name, and then the curly brackets here, 0, 1, something, and then you have to add the variables you want it to display in order. As you can see, I add the module ID here. The importance of this is, for example, you generate a bomb with 5 of fastmat module. Each of them will have the unique number attached to it, such as fastmat number 1, number 2, number 3 to number 5, and then when the user loads it into the log reader, the log reader will separate them automatically and user can analyze the gameplay very easily. If you don't do this, everything will clutter and the user will have no way to know which module is which. Okay, so let's continue. The next part is these Boolean variables, is solved and lights on. These are also very important because of for the is solved Boolean basically tells that the module is solved or not. If the module is solved, the buttons should still behave like a button. You can still click on it, have a response, but don't actually do anything. Is solved Boolean is gonna help with this. And the lights on basically tells that the timer is started or not. You don't want the user to be interact to the buttons before the light is on, because sometimes the user will be able to answer the default answer such as 00 or answer some invalid answer and get a strike or pass immediately before the timer starts. We don't want that. The isSolved Boolean must be set to true after the user passed the module, like this. And as you can see in the block of code here, if the module is solved, the button handling functions will return immediately without doing anything. And then for the lights on, it will be set to true in the activate function here. The activate function is called from here module.onActivate, which we'll call the activate function. After this function, the light is now on and the timer starts, so you have to set it to true here. And during the button handling, if not lights on, again it will return immediately without doing anything. So next is the functions that comes with the game. The first is the start function. This function is used for first incrementing the module ID counter and for the activation of the module. Here the activate function we'll call the initialize function for setting the module stages, initial stage, and put the lights on. Then the awake function, this function will handle all the button pressing. The interaction will be put in the delegate function. This is the delegate function for one button, and this block is for multiple buttons, which is the type came selectable, putting in a array like this, the button I array. The important part of getting the array to work in for loop is this thing, int j equal to I, because if you just add I to the press handling function, it will not work. It will return the first value always. You just have to do this. This trick will work just fine. The next part is the running of the code itself, the random part of the game, just like this one. Unity has built-in function for randomizing the numbers in floating point and integer, just like this one. I call the random range from 3 to 6 for randomization of the amount of stages the module will have. Since in the manual legend said that it will have 3 to 5 stages, if I want to randomize the integer between 3 to 5, I have to set it to 3 to 6 because the upper agent is excluded. So basically 6 is not possible in integer generation. But if I want to get the floating point randomization, I can use 3, 5, and it will work. You can check the Unity manual online for this for more information. So the next part will be this block of code. If you want to change the tint color of the for example the button, you have to invoke the command like this. Basically call the button. This is the mesh renderer .material.color, and then you can set the color in like this. You can use color 32 like this for setting in the RGB value, and the last one must be 255. And or you can use the built-in colors such as color.gray. Both will work. And then I will go through the function. This is the init function. We call. It will randomize amount of stages find the threshold second for countdown, and then generate the first stage and reset all the variables. This is used in case the module got a strike or timeout, and it will reset everything back to the initial stage. For the generate stage, it will fall into this function, which will again random the characters, put it on the screen, and then it will query the table here for the initial numbers and then apply rules to it. And you might notice these commands. These are the commands available when you use the KTaNE bomb info extension file by @bash. I will make the separate video about it, so I can get the HWork details, such as is the lit MSA indicator present, is there a serial port, is the serial number contains the letter F, A, S, or T, or something like that. Get the battery count more than 3 or something like that easily. Then we go to this coroutine. Okay, I will skip it for now. And then when the module is loaded, when you start playing, you have to press the go button first. So when the go button is pressed, it will first do this command, which is basically add the punch sound, the button punching sound. And this line, add interaction punch, will make the bombs slightly push, like we push a button on the bomb. And this is a check if the go button, if the light is not on, the module is solved, or the go button is already pressed, it will return. And then these will this command will change the color of the go button or something like that, and then it will start the countdown coroutine actually, and then set that the go button is already pressed. And then this is the coroutine function of the type IEnumerator. So what is this means? Normally, if you perform the command in C#, the command in the function will be run to the end and then before it is returned. So if you want to, like, let's say scaling the game object 10 times in 10 seconds, if you do that command like in for loop from 1 to 10, it will immediately go 10 iterations without any delay. The coroutine solves these problems by running the command on the first iteration, then wait for like let's say 1 second, and then continue with where it left off on the second iterations outside of the normal running of the code, so you can still continue running all of the commands without worrying about how the countdown or scaling will be performed. So basically this function here I will declare the delta floating point for the how much the number will change during one iterations, and the current to tell the current stage of the changes. Then the for loop will iterate equal to amount of the threshold, or basically the set countdown times. Let's say the default 10 seconds. What will happen each second is the game object will rescale to the current According to the current variable, the bar color will lerp from green color to red color. This is the built-in Unity function as well, from changing color from green to red gradually, stayed by the current floating point, and then it will subtract the delta out and then wait for 1 second. If the user solved the stage before the time ran out, the coroutine will be terminated and will be restart in the new stage without giving a strike. But in any case, if the user did not respond in time, the function will go out this for loop and then reset the bar local scale to none, and then it will time out. So the next part is handling the numeric button. This is just the some math functions. I will skip this one because it's not that important to talk about. And then this is the answer checking function when the user press the submit button. As you can see here, it will first stop the countdown coroutine, so it will not accidentally cause a strike by timeout after the submit button is pressed. And then it will check the input answer generated by the hand press function against the calculated answer. If it matched, it will continue to the next stage. But if all the stages are done, as you can see, compare with the stage amounts variable, the module will pass. This command here will play the voice, the audio file called disarm, which I added here. To add the custom sound file to Unity, you have to convert the file to awk-var-based file and then add it to the assets folder. Then you can invoke the command audio.playSound@transform to play, and then the name of your sound file and the transform you want to invoke this action, just like this. But if you want to play the built-in sound of the game, you can invoke the command audio.playGameSound@transform, and then the sound name, as like this one. This one is the button pressing sound, and then the transform that invoke this, which is the submit button. And then continue with this. We reset the bar, reset the screen text, and the module is passed. This command module.handlePass will tell the bomb that this module is solved, and we set the solved boolean to true. But if not stages are completed yet, it's not complete yet, I will play the sound pass stage and then regenerate the next stage, reset the input answers, and then start the coroutine again. But if the answer is incorrect, the command module.handleStrike will tell the bomb to give 1 strike, and the init function is called again, basically reset the whole process. And this is the function for handling the timeout. If the user did not respond in time, it will stop the coroutine and give a strike and reset again. And then we come to the last thing here in this video, which is the mod settings. This is a bit tricky. First, you have to, in your module, you have to add the KTaNE mod settings to the prefab, and then you have to make a class called mod settings or JSON, actually any name, and then include all of the settings you want to add in your files. Then declare this KMod mod settings, and then write this function. I recommend put the command inside the try catch to get catch the JSON reading exception so that the game will not crash and will just return the default value if in any case something does go wrong. And then invoke these commands. This is a JSON class we created above, and we name it settings, and then we deserialize the object. The object will be we will deserialize will be the mod settings dot settings. This is the default. This is the fixed name, and then you do all the decisions here. You do all the comparisons here and return the desired value, which is in this case specify the countdown time. After you write this piece of code, you have to write the JSON mod settings file for it, and you have to name it mod settings.json. As you can see here, we have a variable called countdown time and node, just like in our C# file. In our script file, we name it the same. And then you have to save this file in your assets folder. Here, you have to follow the JSON format as well. And then you have to copy the whole file and place it inside the settings box here. And you are all set. Thanks Ask the Bash for helping me with this. Okay, so after all those scripting, we are now ready to test. First, go to the console tab and make sure that the collapse box button is not checked. Clear it, or else you will get some confusion while testing, because Unity will collapse all the message with the same text in one line, which we don't want this to happen. Then another thing is, if you got this warning from testharness.cs at line 686 about testharness.lite, you can ignore this. This will not have any problem. This will not get you into any problems. Then in the hierarchy scenes, make sure you drag the testharness prefab in, and you can press play to test your module. Okay, so our module loads. Then, okay, the light is on and the timer is now counting down. Then you can test about lights on and lights off behavior of your module. If your module is needy, you can activate and deactivate it here. And then on the console below, you can see the locking is working. As you can see, the fastmat 1 here and the stages and everything. And then we can test it in the stage 1. The calculated answer is 12. You have to check your manual and try calculating it against the locking as well, in case you may have some bugs in your code. In this case, they have tested thoroughly and nothing is wrong. So I would just press the go button, and then as you can see, the time is running out, the bar is going down. I will submit 12, and as you can hear, the sound is played. Okay, next stage is 27 and 16 and 16 again, and the module is passed. 2 rings here. you can see the module passed, and since this virtual bomb has only one module, the bomb is diffused as well. And that's it. Thanks for watching. If you have any question, please comment down below. If you like the video, please like and subscribe. Thanks for watching, and see you in the episode 5 where we publish our module to the Steam workshop.